So in this lesson, I'm going to explain how the mole is your central unit. And the reason why your mole is your central unit is it allows you to convert between different modes of measuring the amount of a specific substance. So for example, I can measure the mass of a substance, I can measure the volume of a substance, assuming it is a gas, and I can count the number of particles, so either atoms, formula units, or molecules. And in order to convert between all of those different ways of measuring the amount of a substance, I need to use the mole. So the first thing I can do is I can actually convert between a mole and the mass, which is measured in grams. And the way that I do that is I use the molar mass of the substance in question. And remember, the way that you calculate the molar mass is you add up all of the average atomic masses of the elements that make up that molecule or that formula unit or that atom. And once you add all of those masses together, that's what gives you the molar mass of the substance. So I'll show you an example in a second of me doing that. Okay, so to go from moles into mass or mass into moles, you need to use molar mass as your unit conversion. You can also go from moles into particles. Now remember, particles, we will refer to particles as either atoms, molecules, or formula units. So we refer to particles as atoms when we're dealing with one specific element. So for example, copper atoms or iron atoms. When we have a molecular compound, like for example, carbon dioxide or nitrogen dioxide or water, for example, we refer to the particles as molecules. Those are substances that experience covalent bonding. So those would be molecules, two nonmetals. Okay? We refer to particles as formula units when we have ionic compounds. So remember, that's a metal with a nonmetal. So for example, sodium chloride, iron oxide, whenever you have a metal and a nonmetal together. Okay? So to go from moles into particles or from particles into moles, I'm going to be using Avogadro's number, which is 6.02 times 10 to the 23rd. Now if you notice, looking at this diagram here, I can actually go from mass into particles. And the way that I do that is I would first go from mass into moles and then from moles into particles. And I'll show you how to do that in just a minute. Okay? The last way of measuring the quantity of a substance is volume. Okay? Now, I can convert from moles into volume, but the one thing to note is that your substance must be a gas, and it must be a gas at STP, which is standard temperature and pressure. If it is at standard temperature and pressure, then I know that the volume of 1 mole of gas at STP, 0 degrees Celsius and 1 atmosphere, the volume is 22.4 liters. So 1 mole is 22.4 liters. So looking at this now, I can go from volume into mass, volume into particles. I can say, okay, if I know the volume of a gas, how many particles will it have? In order to do that, you first need to get into moles, okay, by using the conversion factor. So if it is a gas at STP, you can use the conversion factor that 22.4 liters equals 1 mole. If you've got particles, you can use Avogadro's number, 6.02 times 10 to the 23rd. And if you have mass, you can use molar mass. So let's look at an example. All right, so here I'm given 0.5 moles of glucose, and I want to convert that into grams. So I'm first going to write my given, which is 0.5 moles, and I'm going to convert that into grams. So I'm going to put moles on bottom so that they will cancel each other out, and I'm going to put grams on top. Now, keep in mind, thinking back to the diagram on the previous slide, I need to use molar mass in order to achieve that conversion. Molar mass, what I need to do is look up the average atomic mass of each of these atoms. So carbon has an average atomic mass of 12.01. So I'm going to take that and multiply by 6 because I have 6 carbons. And I'm going to add to that the molar mass of hydrogen, which is 1.008. Multiply that by 12 because I have 12 hydrogen atoms. And then I'm going to add to that the molar mass of oxygen, which is 15.999, and multiply by 6. And so what that gives me for the molar mass is approximately 180.156 grams. Now, I put the 180.156 in front of grams because the units for molar mass are grams per mole. So there are 180.156 grams for every 1 mole. And so what I now need to do is simply multiply, because the 180 is in the numerator, so 180.156 times 0.5 gives me approximately 90 grams, and it's 90 grams because I rounded to just one significant figure, okay, because 0.5 has just one sig fig. All right, let's look at a slightly more challenging problem. It says how many molecules of hydrogen are in 3.36 liters of hydrogen gas at STP. So my given here is 3.36 liters, okay? Because I want to get into molecules, remember I first have to go into moles. So I'm going to put liters on bottom to cancel them out, moles on top. Then I'm going to keep going because I don't want to stay in moles, I want to get into molecules. So I'm going to put moles on bottom and molecules up top. Now I know the relationship between moles and liters because I am at STP. So at STP, because I have a gas, hydrogen is a gas, for every 1 mole I have 22.4 liters. Okay? And then I know the relationship between molecules and moles by using Avogadro's number, which is 6.02 times 10 to the 23rd molecules for every 1 mole. And keep in mind that it is going to be molecules because hydrogen gas is actually H2, and so that has a covalent bond, so we're going to refer to that as a molecule. And so when I take 3.36, divide by 22.4, and then multiply by Avogadro's number, I get the total number of molecules to be 9.03 times 10 to the 22nd molecules. So I'm going to start off, I'm in grams of sodium sulfate, and in order to get into formula units, I need to get into moles first. So I'm going to put grams on bottom, and I'm going to put moles up top. Now I've got to put the molar mass of sodium sulfate on bottom, so it's 142.05. I'm now in moles of sodium sulfate, and I have to get into formula units. So I'm going to put moles on bottom, and I'm going to put formula units up top. Remember, you've got 6.022 times 10 to the 23rd formula units for every 1 mole. Okay? And now I can actually figure out how many formula units that is, and it's 1.93 times 10 to the 23rd formula units. All right, so now instead of just doing one simple conversion from grams to moles or moles to grams, you now can go from grams into moles and then get into something else. What happens if instead I'm asking for the mass of, for example, iron, when I give you the mass of iron oxide? Well, I can do, it's extremely similar to what we just did, except now I've got to figure out how much iron is in that iron oxide, and in order to do that, I've got to use a mole-to-mole ratio. So what I'm going to do is I'm going to start off in 25.0 grams of iron oxide. I'm going to get into moles of iron oxide. So I'm going to put grams on bottom and moles up top. 1 mole for every, now I got to put the molar mass of iron oxide, which is 159.7. Now I'm in moles of iron oxide. In order to figure out the mass of iron I need to get into moles of iron. So I'm going to put moles of iron oxide on bottom and moles of iron up top. If you look at the formula, for every 1 mole of iron oxide that you've got there, you've got 2 moles of iron. So it's a 2 there and a 1 there. Now I'm in moles of iron, and it's very easy for me to get into grams of iron. So I'm going to put moles on bottom and grams up top again. Got to put the molar mass of iron, which is 55.85 for every 1 mole of iron, and then I can get my answer, which is 17.5 grams.